This is our dynamics lesson 3. Maybe last one we will see how I fit all the questions in one video. But this one is going to include the inclined planes. And we have done similar questions with vectors, but let's look at how we're going to solve questions with the inclined planes. So I'm going to make an example here, and with this example, we're going to try to solve based on what is given. So I'm going to say the angle of the incline is 30 degrees, and the mass of the box, let's write the mass of the box. So I'm gonna write it a little bit higher and say the mass of the box is, let's say, 2 kilograms. And let's write, and the coefficient of friction, let's do coefficient of friction, mu, when it is sliding, and we're gonna say that it is sliding, is 0.1. Let's write all the forces that are given. So the force of gravity is acting on the box. This is mg. Then the normal force is acting on the box because it pushes on the incline pushes back, so the normal force. And the friction is there. So these are the three forces that I have written acting on the box. And the box is going to accelerate. So I'm going to do it in different color. So acceleration is going to be this way. And I want to find the acceleration. So for these problems, my acceleration is not horizontal or vertical. This is why I'm going to choose my x and y coordinates aligned with the acceleration. So my y-axis is going to be like this, and my x-axis is going to be like this. I'm going to choose positive direction up, and direction of the acceleration is positive. I always will choose direction of the acceleration is positive. Now, it is kind of strange to look at your y and x axis this way, but we have to, because otherwise we would have acceleration on x-axis and acceleration on y-axis. So we will just keep our coordinate plane with the acceleration. Now I need projectiles. So I need my normal force is aligned with the y-axis, and my friction force is aligned with x-axis. But my force of gravity is not. So for the force of gravity, so I started with this point, the green one, and then I'm going to go along the y-axis to get to my mg, and then I have to turn to the right and get this way. So this is my path for getting to my end of the vector mg. Now I'm going to determine my theta here, and this is the tricky part. So if I'm going to scroll here and come back to this question in a minute. If I have my incline, and this is my theta, this is a perpendicular line. So I mean these are the right angles, these are the right angles. Then this angle is 90 minus theta. Because in a triangle, I'm going to do this in green. In this green triangle, the sum of all angles must be 180. So if I have 90, the right angle, plus 90 minus theta, and plus theta gives me 180 degrees. So the other angle must be, this angle must be 90 minus theta. Then I'm going to drop this line right here. Now this one is 90 degrees. Then this angle is 90 minus theta. But the whole right angle right here was 90. That means this angle must be theta. So now if I come back to this problem, this angle is theta. So this is 30 and that is 30. So these two angles are 30. You see, like, this is the same angle as that one. So now I know where my angle is. Then for the vertical part of the mg, that becomes mg cosine because it's adjacent to the angle, and the horizontal one, the x component, is mg sine theta because it is opposite of the angle. Now I'm gonna do my F net forces. So we decided that the mass is 2 kilogram. I'm gonna write right here 2 kilogram, and mu is 0.1. So now I'm gonna write my forces on y and x axis. Let's start with y. On y, my forces cancel each other. So on y, I have the normal force, and I have mg cosine. These two forces cancel each other because there's no acceleration on the y-axis. So I'm gonna write the normal force is up, so it's the normal, minus, I chose the force up positive and down negative, minus mg cosine theta. So what I'm doing is the net force is equal to ma, but in this case my acceleration is 0. Vertically I don't have any acceleration. So for the next one, it's the x-axis, and on the x-axis I have, let me do just this color, I have friction force, and I have mg sine. So I chose acceleration direction positive, so mg sine is positive. I have mg sine theta minus the friction force is equal to ma. I have acceleration along the inclined plane, so that gives me equals to ma. I'm gonna solve, again we're back to system of two equations. I'm gonna solve the top equation for normal force. So my normal force is equal to mg cosine theta, and I know that friction force is mu times the normal force. So I'm gonna rewrite as mg sine theta minus, and instead of writing friction, it's mu times n, but n is equal to mg cosine theta, and all of this is equal to ma. I see all of them have m, so every single term in my equation, so this term has m, this term has m, and this term has m. Every single one of them has m. I can divide each term by m, so m cancels. What's left is g, I'm gonna take g out, sine theta minus mu cosine theta is equal to a. So I can find acceleration of my box. G is 10. I have sine of 30 minus mu, which is 0.1, cosine of 30 degrees. So acceleration is equal to, I got 4.134 meters per second squared. This is just an example. It's not one of the questions that you have online. I just made up one question. What I wanted you to understand from this question is the forces that are acting on the box and the angles. So to take away from this problem is the normal force is again perpendicular to the surface. The force of gravity, mg, is broken into two forces. One is mg cosine, the other one is mg sine, and this angle inside of the triangle is the same angle as the incline. and then there is a friction force that is opposing the motion of the object. So these are the important things, and we're going to be looking at different problems related to this concept that we just did in this problem. Let's look at this question. A skier starts from rest at the top of a frictionless incline of a height of 20 meters and angle of 30 degrees with the horizontal. At the bottom of the incline, the skier encounters a horizontal surface where the coefficient of friction, kinetic friction between the skis and snow is 0.2. Neglect the air resistance. Find the skier's speed at the bottom, and then how far does the skier travel before he stops? Because of my limited space, I'm just going to highlight everything that is given. So the height is given 20 meters, the angle is 30 degrees, and the coefficient of friction is 20. And it is along the line, the horizontal line. It's not on the incline. On the incline, they say there's no friction. So the forces acting on the skier, I'm going to do it here. The normal force, the force of gravity, and that's it, because there's no friction. So the force of gravity, it will be broken into two forces, vertical and horizontal, and I already know that this angle is the same as the theta angle. So that gives me the vertical force is mg cosine theta, and the horizontal force is mg sine theta. So the two forces, vertical and mg cosine, cancel each other, so there's no acceleration that way. Acceleration is down the incline. So for my free body diagram, I have the normal force and mg cosine. So the normal force, what I'm doing again, I am doing F is equal to ma. The net force is equal to ma. Always start with this formula. So my vertically, I have the normal force up minus mg cosine, and there is no acceleration vertically, so that is equal to 0. And horizontally, I have only one force, mg sine theta, and that is equal to ma. I don't have friction, so I don't need the normal force. I will usually need the normal force when I have friction. So from the second equation, I can see I can cancel m's, and I can find the acceleration is equal to g sine theta. And g is 10, and sine of 30 degrees is 1/2, so that gives me 5 meters per second squared. Now, since I know my acceleration and the height, so I'm gonna make this triangle right here again. I have a triangle, and I have 30-degree angle right here, 30-degree angle, and h is given 20 meters. Then I'm gonna call it theta. So sine theta is equal to h, and I'm gonna call this distance, the one that he's traveling down the incline, over the distance. So the distance is equal to h over sine theta. So the distance is equal to 20 divided by sine of 30 is 1/2, gives me 40 meters. So he's going to travel 40-meter distance. So if I want to find the final velocity at the end of the incline, this velocity, I have the distance and I have acceleration. It's that formula. So the final velocity is going to be equal to the square root of 2 acceleration and the distance. So that gives me 20 meters per second. So when the skier gets to the bottom of the incline, his velocity is going to be 20 meters per second. And I need a little bit more space here. I'm going to erase because I need another free body diagram. So it's going to be clean after I pause it. So I figure out the velocity, the final velocity is going to be 20 meters per second. So by the time he enters horizontal surface, his velocity is going to be 20 meters per second. Now I'm gonna draw his body right here and draw the forces acting on him. So let's say that is him. So he has another normal force acting here when he's moving horizontally. He has force of gravity acting on him, and now he has friction acting on him. So I'm gonna do again F net is equal to ma. I have the normal force minus mg for horizontal motion is equal to 0 because there is no acceleration, so ma is equal to 0. For the vertical forces, I have only one force, the force of friction. So the friction force, negative, is equal to mass times acceleration. They don't give me the mass of the skier, because when I say mass, it's the mass of the skier. But I see that the normal force is equal to mg in this case, and the friction force is equal to mu times the normal force, which is mg, and equals to ma. If they don't give me the mass, there's probably a reason, because mass just cancels. So I can figure out new acceleration on the horizontal incline. So this is a new acceleration, this is not the acceleration that we used to have, and I'm going to put a star right here. This is a new acceleration. And this new acceleration is mu times g, which is negative 2 meters per second squared. So he's slowing down at 2 meters per second each second. So if I want to figure out the time it's going to take for him to stop, because I need to know how far, so I need the time. The time is the change of the velocity over the acceleration. Acceleration, not the g. And in this case, final velocity is 0, initial velocity is 20, and acceleration is negative 2. So it looks like it's going to take him 10 seconds to stop. Then I can figure out this distance that he will travel before he stops, this distance. So I have the distance is equal to average velocity, so he enters with 20 and then he stops. Final is 0, so average velocity is 10, and time is 10 seconds, so that gives me 100 meters. So he will travel 100 meters before he stops. Here's another example. 250 Newton force is directed horizontally as shown to push a 29 kilogram box up the incline at a constant speed. Determine the magnitude of normal and the friction forces. Determine the coefficient of friction, mu kinetic friction. So the mass of the box is given. This is 25 kilogram. The force that is acting 250 newtons, and the constant velocity. So constant velocity is important. So let's write the forces that we know. So there's going to be a normal force, the force of gravity. There's going to be normal force as well. The normal force. It's being pushed up. So the box is moving up. The coefficient of friction and the friction force are horizontal. So here is the friction force. And I need to, again, choose my axis. So here is my axis. This is my x. This is my y. And I'm going to choose their direction, positive direction. And the force that is acting, so this force that is acting, it is not aligned with any of the horizontal and vertical lines. So I need to make projections of it. So I'm gonna drop the one that is perpendicular to the surface and the one that is horizontal to the surface. And this angle is the same as that angle. So these two angles are the same. So if this is the applied force, then this is F sine, and the one that is at the bottom is F cosine. So the one that is horizontal, F cosine theta. Now I'm going to write my, and then mg. mg needs two forces. So I have these two forces, and mg needs to be aligned with my coordinate plane as well. And this would be your angle, right? So this is the angle and that is the angle. So for vertical forces, I have the normal force is vertical. I have mg cosine, so I have the normal mg cosine because this force is touching the angle. And I have F sine down, right? And I have F sine down force. So I have these three forces in yellow. So there's no vertical acceleration. So the forces up are positive, the forces down are negative. So I have the normal force positive, the net force, I'm writing the net force, minus F sine down, minus mg cosine equals to 0 because there is no acceleration on y. Then I'm going to do my horizontal forces in blue. So I have f cosine theta. I have friction force, and I have mg sine. So for x-axis, I have f cosine positive minus friction force, and minus mg sine equals to 0 because there is no acceleration. They said it's a constant speed. So horizontally there is no acceleration either. Then I'm gonna move all the actually let's solve for the normal force, the top equation. So if I solve the normal force, the top equation, I have the normal force is equal to f sine theta minus or plus mg cosine theta. And if I plug it in instead of friction, I will get f cosine theta minus friction, mu times n, and n is f sine theta plus mg cosine theta minus mg sine theta, and equals to 0. Let's look at the information that is given here. So force is given, that one is 250. Cosine of angle is given, angle is 27 degrees. Then mu is the one we're looking for. Force is given, sine is given, mg is given. So everything is given, all I have to find is mu. So let's solve for mu. If I solve for mu, I have to move it to the other side. So what I have on this side is f cosine theta minus mg sine theta is equal to mu f sine theta plus mg cosine theta. And mu then is equal to f cosine theta minus mg sine theta divided by f sine theta plus mg cosine theta. And that is equal to, so I got my mu equals equal to 0.245. And I forgot that they asked me about the normal force and the friction force. So my normal force, the normal force is equal to, from the first equation, the normal force is equal to f sine theta plus mg cosine theta. So the normal force is equal to 371.9 newtons, and the friction force is equal to, so my friction force, I'm drawing where the graph is, the image. So my friction force is equal to plus this force, plus mg sine, is equal to f sine, because they cancel each other. So these two forces, friction force and mg sine, so your friction force plus mg sine force is equal to F sine force, sine theta and theta. They cancel each other because the velocity is constant. It moves at a constant velocity. So from here I can figure out that the friction force, if I plug in the numbers, is equal to 91.14 newtons. So I have time to solve one more question in this video, so I have to make another video. So I'm gonna do this question. A 50 kilogram bucket is being lifted by a rope. The rope is guaranteed not to break if the tension is less than 574 newtons. If it starts from rest, so initial velocity is 0. If it starts from rest and after being lifted 5 meters, it is moving at 2 meters per second with constant acceleration, is the rope in danger of breaking? So it moves the distance of 5 meters and it started with 0 meters per second and the final velocity is 2 meters per second. And I can figure out the time. So the distance formula, it gives me the average velocity times the time. So the time is going to be equal to the distance over the average velocity. The distance is 5 meters and average velocity is 1. 0 and 2 gives me 1. So the time it's going to get to this new velocity is 5 seconds. With this information, I can find acceleration. Acceleration is the change of the velocity over the time. So my initial velocity is 0, my final velocity is 2, the change of the velocity is 2 over 5 seconds. So the acceleration is 0.4 meters per second squared. Now let's look at the forces acting on the bucket. So I have tension force and I have mg, the force of gravity, and I also have acceleration. So acceleration is upward. So I'm going to use my F net is equal to ma. The forces that I see, tension is positive, it's up. Mg is negative. It is down. And equals to mass times acceleration. So from this equation, I use the net force is equal to ma as always. After a free body diagram, I always do my F net equals to ma. So from here, I can see that tension is equal to mg plus ma. So the tension is equal to, the mass is 50 kilogram, g is 10, and acceleration is 0.4. So that gives me tension is equal to 520 newtons. So it looks like the rope is not going to break. That is it for this video, and I have to make another one, so hopefully the next one is the last one. See you in the next video.